Hello everyone. This is Agrigo presenting Agri-Aqua filter and distillation system. I'm Hente.
I'm Sonia.
I'm Edward.
I'm Rachel.
I'm Ryan.
So the problem we're trying to solve is called agricultural runoff, which happens when water from farm fields flows to the earth and carries harmful pollutants to bodies of water that we drink from and organisms inhabit. And the statistics on the side are meant to show the large scale of our problem. So this is a quote that we use to inspire our product by the Environmental Protection Agency. And it basically says that farmers can implement practices to significantly reduce runoff. So what's our solution? So we have a multi-step filter system, and our first filter is meant to keep nutritional particles such as bugs and soil. And then these particles move into a separate storage tank. Then the water moves into a pump with nano-sized mesh for reverse osmosis and activated carbon for extra cleaning. Then when the water overflows, it'll enter a line of shrubs. That's called a conservation buffer that many farmers use already to intercept the extra pollutants. And finally, the water will lead into big bodies of water or be recycled.
So here's our prototype design from a larger perspective. On the very right, you see where the farmland ends, we build a fence with a grate. And then behind that, we would have a concrete channel that would be slightly sloped downwards with our filter system in the middle. And then on the very left, before we hit the water source, we will put a deep-rooted shrub, our conservation buffer. So if there's a storm or a flood or anything like that, the water would go into the shrub and the harmful nutrients would go into there instead of directly into our water source. And here we get a closer look at the filter diagram. There will be the wire grate at the very right, which would be where the fence is. And that's just supposed to keep larger particles like clumps of dirt, washed up plant material, and bugs from entering our pump and our filters and clogging everything. Then the water would go through a cycling pump, which would push the water with all of its chemicals into a first filter, and then into a activated carbon filter to get rid of all of the organic waste. And then finally through a nano TFC membrane filter, which is a very efficient filter at getting rid of particles that are typically too small for normal filters. Eventually, it would be drained into pipes that would either go to recycling tanks to be reused or the water source. And here's the nanoscience behind it. Our first filter would be a TFC membrane nanofilter, which is made up of thin film composite membranes, a polyamide layer on top of a porous layer. And what it is a semi-permeable membrane with nano-sized pores, which are smaller than 200 nanometers, and it is very efficient at filtering out heavy metals and dissolved salts. Our second filter, our middle one, would be an activated carbon filter, which would be filter paper with activated carbon inside. Activated carbon is made up of linked chains of or sheets of aromatic rings, and it has a very high molecular surface area, which makes it very, very efficient when it comes to wrapping around and neutralizing organic compounds. And any of the used carbon can be collected and processed to make recycled fertilizer. And then finally, we have another TFC membrane, which ensures that no carbon particles stay in the water, making sure it's clean. And having the variety of both types of membranes ensures that our filter can remove heavy metals, nitrate ions, phosphates, organic matter, and many other harmful waste products that would come from farm runoff. We optimize our system to recycle as much as possible, and all the carbon can be renewably sourced. A very common one is cow bones.
Who's speaking now? And are they having computer troubles?
So to compare to other products, we have the field buffer that we talked about earlier that is already included in our product that farmers use to line up shrubs so that the extra water will be absorbed. And then the second type is conservation tillage, which is a farming technique used by farmers, but while it reduces erosion, it also increases the dependence on herbicides.
So one product that compares to ours is from the Nutrient Energy Water Tech. They basically use sand and iron as a filtration treatment, and they are able to harvest nutrients and turn it into fertilizer. But it is a mobile facility, and it weighs 9 tons and it's 40 feet long. So it's not very user friendly, and it's not on the market as well. So now for our market analysis, we chose to do 2 approaches. One is to pitch to the EPA, and the second was direct consumer business model. So for the EPA, we had a couple of grants that we could apply to, including SBIR. The EPA does have a lot of funds specifically for agricultural related projects, so this would greatly relieve a lot of our financial expenses. And for the direct-to-consumer model, we would be able to visit conventions to publicize our product and gain more clients. So our total addressable market would be the approximately 2 million farms in the US, and out of that, we would want to focus on the farms near bodies of water. So our target market would be the farms directly affected by agricultural runoff. So for the first 3 years, we would want to go a little slow because we would not be able to do clinical trials, so it would not be a good idea to mass produce. The first 2 years, we would do 10 installations, roughly costing $30,000. So the cost to produce one installation, which would be 100 meters worth of the filter, would be $3,000. So we would charge, so it would cost $13,000 in total. And in terms of grants, the average SBIR grant is $300,000. So if we apply to multiple grants or directly approach the EPA, we can raise this.
So for our business plan, we're targeting farmers and governments, and our type of a product is a water purification dam, and we'll be spending $0.9 million in the first year and around $1.3 million in the second year, and $1.6 million in the third year. So for the first year, we would primarily be advertising. So we would visit conventions to publicize ourselves and gain clients. Also, we would operate experiments in local farming areas and apply for a patent. In the second year, we would be placing around 5 to 10 products in each state in the US that have mostly to do with agriculture, such as Iowa, California, Minnesota, and other places like that. And since our company is going to be growing, then we would employ more workers in the company. And for the third year, as hopefully, as approaching the third year, our company would be well known. So we would have international patents and spread our product over regions that centralize agriculture, such as in West Asia and Africa. And Myanmar is located in Southwest Asia. So back when I went abroad to Myanmar, I was located in the biggest city in the country, Yangon. Even though it was the biggest city, vast amounts of fields were covered with agricultural fields. So our product would be most desirable in places like this, and we would still continue our influence of our product in the US, and hopefully as time goes on, we would be a larger scale company.
And so, in terms of intellectual property, due to the nature of our product, probably the best document to aim for would be a patent. And the reason why is because our idea falls within kind of the realm of being a novel and non-obvious type of machine. So it's eligible for a patent. And the reason why we would want to get one is because there's actually little to no current competition for ideas such as this one currently on the market. And so getting a patent would protect us from other entities that may try to find and reproduce our idea. So on one hand, if we were to opt out of the patenting process, entities that find our idea could steal or reproduce it very easily and just make maybe like slight modifications or improvements to our product. And then we would have competitors with a stronger product, which would be a bad thing. But on the other hand, if we were to opt for a patent, this threat would cease to exist and actually become a benefit for us because we would actually have little to no competition. And it would be costly, and it would also take some time, but doing so would be very necessary just to ensure that we protect our intellectual property. And so some of the assets of our product, there are many actually positive aspects that our product possesses. Some of the most notable are the following. It can actually have many long-lasting positive effects on the environment, as you know, it will filter water very well, and it can actually protect bigger reservoirs of water. There are no major threats or competitors on the market currently. It allows for the collection of excess water. Farmers can even maybe recycle the water that they are collecting that would have been runoff. The product is designed in a way such that it will protect itself from overflow or clogging or any of that sort of thing. So it's very safe, and it's easy to replace the parts of our product as well. And the product is also eligible for a patent, so the intellectual property can be protected. And so, yeah.
So as we leave you here, we want you to make sure you save water, you save lives, and you save the world. And the best way to do that is with Agrigo.